Okay, example 4 asks us to find the range of values of x for which this curve is increasing. So any curve is increasing or decreasing when the dy by dx is either bigger than 0 or less than 0. So we're going to have to differentiate first. So we're going to get the general gradient. Okay, so let's get our general gradient. So dy by dx so we're going to get 12x to the power 3 minus 18x squared. We want to find the range of values of x for which the curve is increasing. So curve increasing, we set dy by dx bigger than 0. Okay, so we're setting 12x cubed, subtract 18x squared, and that is bigger than 0. We have an inequality, so I'm going to divide through by a positive here, just to keep things right. Never divide through or multiply through an inequality by a negative, because that would have to cause you to change the direction of the inequality sign. We want to try and avoid that. So I'm going to divide through by 6. So we're going to have 2x cubed minus 3x squared, and that's bigger than 0. Now, we are left with an inequality here that is not quadratic, because the highest power is not 2, and it's also not linear because the highest power isn't 3. So we actually have a cubic inequality here. So we can't sketch the left-hand side. Instead, what we're going to have to do is ignore the inequality sign, solve it as if it's an equation to work out the critical values of x. We're then going to investigate the sign of the left-hand side here, 2x cubed minus 3x squared. We're going to investigate the sign, SIGN, of that around the critical values. Okay, so not a quadratic or linear inequality. So instead we have to investigate the sign of the left-hand side, the non-zero side, around the critical values. Now, let's get our critical values. So to do that, you ignore the inequality sign, pretend it's just an equation. So with 2x cubed minus 3x squared equals 0. I'm going to factorize, I'm going to lift out x squared. So we're going to have x squared upon 2x minus 3 equals 0. Product of two things equals 0. So if x squared equals 0, that means x equals 0. Or the bracket here equals 0. 2x minus 3 equals 0, so x is going to be equal to 3 over 2. So these are our critical values. Now what we're going to do is we are going to investigate the sign, SIGN, of the left-hand side of the non-zero side of the inequality around these critical values. So we're going to investigate the sign of the non-zero side around the critical values. So we're going to draw a table. So the top row in our table are going to be the x values. The bottom row in the table is going to be the sign, SIGN, of the non-zero side of the inequality. So 2x cubed minus 3x squared. Okay, now the critical values are 0 and 3 over 2. So we want to investigate the sign of 2x cubed minus 3x squared between the critical values and either side of them. So first of all, we're going to consider what happens when we sub in an x value which is less than the critical value of 0. So we're going to look at subbing in an x value which is less than 0. We're then going to consider subbing in an x value that's between 0 and 3 over 2. So that's going to be 0 less than x, which is less than 3 over 2. And then we're also going to consider the sign of 2x cubed minus 3x squared when we sub in an x value bigger than 3 over 2. So let's take any x value less than 0 and chuck it into the non-zero side of the inequality and see what sign it is. So let's say take x as minus 1, that's less than 0. So we're going to have minus 1 cubed, that's minus 1, times 2, that's minus 2. And then minus 1 squared is just 1, so minus 3 times 1 is minus 3. So we're going to have minus 2 minus 3, which gives you minus 5. So overall this is going to be negative. Let's sub in an x value between 0 and 3 over 2. Let's chuck in 1. So we're going to have 1 cubed is 1, times 2 is 2. 1 squared is 1, times minus 3 is minus 3. So we're left with 2 minus 3, which is minus 1. So overall in this region, the non-zero side is going to be negative. Let's now chuck in a value of x bigger than 3 over 2. So let's chuck in 2. So we're going to have 2 cubed is 8. 8 2s are 16. 2 squared is 4. And then minus 3 times 4 is minus 12. So 16 minus 12 is going to give us positive 4. So for this region here, the sign of the non-zero side of the inequality is positive. So what we do now is we look for the range of values of x which cause the inequality we're trying to solve to be bigger than 0, in other words positive. So what range of values of x cause the non-zero side of the inequality to be positive? Well, it's this one. So the solution is x is bigger than 3 over 2. So our final answer so 2x cubed minus 3x squared is bigger than 0 when x is greater than 3 over 2. And that is our answer. So that's the solution of this inequality. And remember, we set up this inequality from the fact that the curve is increasing. So in other words, the curve is increasing for this range of values of x.